Yo, what's up, everyone? Why did I say everyone? I'm just teaching this to one person. Okay, this is going to cover the form for chapter 5.1. Wait, no, 2. Ionic bonds. Okay, I'll start with the basics. What is an ion? An ion is, let's see, this is an atom. Na. That is sodium. And we all know sodium is a metal. And here's another atom, circle Cl. Chlorine, that is a halogen. And it's non-metal. So look here, metal, non-metal. So if a metal and a non-metal react with each other, you basically get an ion. So let me erase all that real quick. Alright. Now, how does an atom turn to an ion? Well, through ionic bonds. So here's an example. Actually, not an example. Let me just whatever. So you know the electron arrangement for sodium is 2, 8, 1. That means it looks like this. And bear with me. Hold on. It's much easier if I use a fucking circle. Oh yes. Oh shit. Fuck. Holy shit, this is revolutionary. Oh my fucking god. Alright. Na. So look, it starts with 2. That's the valence electron. So you write 2. I mean, not the valence electron. That's the innermost shell. So 2, the start here, the innermost shell is the circle closest to the circle in the middle. And since it has 2, you write 2 x's. Now 8. So you do it like this: 1, 2, 3. You got to move on to the next shell. 4, 5, 6, 7, 8. Looks a bit janky, but whatever. Now there's a third shell, so another circle. And then you just write it. Since it's 1, you just put 1. Voila. See? That's sodium. Bear with me for a while. And this is chlorine. The electron arrangement for chlorine is 2, 8, 7. Now let me fucking draw it. Jesus Christ, it's gonna take so long. Yeah. Shit. Yeah. Don't look at the size. The size doesn't really matter, because I fucking suck at drawing it right now. Like the size on the screen, I mean. Alright, this is chlorine. 2 innermost electrons. Next shell, 8. I'll just do it fast, just to not waste your time. 7. 1, 2, 3, 4, 5, 6, 7. Oh shit. Okay, wait, I did it wrong. This, you're only supposed to write 1 for one atom. Each electron has an X, while for the other it's supposed to be dots, but whatever, man. Alright, moving on. So look at the electron arrangements here. You know what atoms love? They love a stable duplet or stable octet electron arrangement, which basically means, well, for stable duplet, this one basically means the 2 electrons in the innermost shell. So this only applies to like atoms with no outer shell, no other shells than the ones closest to it, which has a max of 2. So it's either that or this stable octet, which means their valence electron shell, which means the outermost electron shell, which is the outermost circle. They want like 8 electrons only. So like for sodium, to if they want a stable octet, which they have here, well, they don't have it yet because there's like one more here. You have to get rid of this one, and chlorine here 288. This is a 7. That's not an octet. That's 7. They need one more electron to turn this into 288. And how does this happen? Well, you see, let me demonstrate it. Hold on. All right. Let me demonstrate it. 281, 287. 1 erased. And then see, stable duplet, stable octet. That's perfect. So, and then over here, you just add 1. 8. So what this means is that this electron over here, remove that, sodium donated an electron to chlorine. So now chlorine looks like this, and sodium looks like this. And like this is a stable duplet octet this is a stable octet electron arrangement because, well, look at this outermost circle. Wait, no, never mind. It has like 0 electrons, so just look into this next circle over here. 1, 2, 3, 4, 5, 6, 7, 8. Boom. That has 8 electrons. Like that means sodium is satisfied because it got the fucking stable octet, if you know what I'm saying. So oh yeah, ignore that, whatever. And chlorine is satisfied because sodium gave chlorine 1 electron to turn the 7 into an 8, which is what they want. I hope you're getting this. I can't really fucking explain it. Alright. Let's just move on. I'm spamming the back button. Hold on. Jesus Christ, you can't go back? Okay. Not sure how to make this any bigger. Whatever. Oh yeah, you can just use new. Don't save. Alright. Next. I should tell you how electrons are negatively charged and how you're supposed to write that through a formula. So basically, Na, sodium, Cl, chlorine. Since usually sodium donates an electron, like donates an electron to chlorine, that means chlorine gets 1 electron. Yay. Look, electron. Zzz. So, and since electrons are negatively charged, that means over here you write a minus sign over there. Usually, well, not usually, since since sodium only gave one electron, that means, well, you'd write one. Wait, no, wrong side. Wait, no, right side. If sodium gave two electrons, it looked like this. But since sodium only gives one electron, like all the fucking time, then it should look like this. And then since chlorine takes one electron from sodium, that means it looks like this, because electrons are negatively charged, right? If you take if you take someone's negative emotions, that means they become positive. So chlorine took the negative from sodium, so chlorine became negative and sodium became positive. You get what I'm saying? Alright, so ions that have a positive charge over here, they are what you call a cation. And ions that have a negative charge over here, they're what you call an anion. These are kind of important. Like, if you look in your book, there's a lot of them, and it's very, very encouraged to memorize them. So, ha ha ha, do as you will. Now, I'm going to teach you how to write half equations, because, well, you kind of need to. Form 5, Chapter 1, it's full of them. So, this is a sodium atom, right? Now, what does a sodium atom do to turn into an ion? They lose an electron. So, let's just put a number up here. He has 2.8281. So he's trying to lose that electron. Unfortunately, in chemistry, there's no minuses. So you'll have to do an arrow, which basically means an equal. Na plus, because it lost an electron, and electrons are negatively charged. So sodium's feeling quite positive today. And plus E minus. E minus is the electron. So, yeah, this is a way to represent it. So, moving on. Yeah, so usually if you want to do half equations, you write the electron on the side that's more positive. So, over here, Cl, since Cl is supposed to turn into Cl minus, you put E plus E minus turns into Cl minus, because chlorine gains an electron from sodium. That means, and electrons are like negatively charged. That means sodium gave his negative feelings to chlorine. So chlorine is now negative. So if you want to write the ionic equation, it look a little bit like this. Hold on, let me remove, just to add a bit more space. Oh wait, no. Fuck, you kind of need these. Alright. I'll just write it down here. So if you need to write the ionic equation, ignore this. Ignore the electrons. You don't need to. That's only for half equations. If you want to write the complete ionic equation, you just take this. You make sure the electrons are like the same number. If they're not, try balancing it. I'll teach you that later. I don't want to teach you this now. So Na plus Cl equals Na plus Cl minus. Now, okay, wait, we can simplify that. Don't do this in your chemistry exam. I'm just trying to make it easier for you to understand. Na plus Cl minus. Alright, wait. if it's Na plus and Cl minus, you're trying to mix together, that means you have to find the charge. So like, since there's no number here, it's obviously 1. So the charge here is +1. The charge here is -1. Then you cross them and remove this after crossing them. So it's just 1, 1. So now 1 for like, there's 1 sodium atom and there's 1 chlorine atom. But since it's 1, don't fucking write that. Now that is the fucking formula right there. NaCl, sodium chloride. That's the crisscross applesauce method, as I like to describe it. Okay, let's do this with a different set of atoms. Mg with a electron arrangement of 2.8.2. Don't say point in exams. That'll fucking destroy your marks. And oxygen, 2,6. Now, look at this situation here. How do you think magnesium wants to reach the octet electron arrangement? And how do you think oxygen wants to reach the octet equation? See, 2.6. How many more electrons does oxygen need to turn this 6 into an 8? And how many electrons does magnesium have to lose to remove this 2 so it becomes just 2, 8? Well, these two match perfectly, because this 2 can be brought here. And that means 6 can be turned into an 8. And then this just turns into nothing. You literally got an ion right there. So since magnesium lost two electrons, which is basically 2 negatives, magnesium becomes +2 because he lost negative. And then oxygen becomes -2 because he gained 2 negatives. Now, if you want to write this in an equation, in a formula, it looks like this: crisscross apple sauce. Boom. Because you move when you crisscross, you only focus on this, the charges. You move them down, and then you get Mg2O2. But since they're the same number, whatever, remove them. Alright. But okay, let's say instead of this, whatever, let's say instead of magnesium, you've got aluminium, which is 3+, and you're trying to bond that with oxygen, which is 2-. These are 2 different numbers. If you want to focus on the charge and do the crisscross applesauce, this is left with 3, and this is left with 2, because after crisscrossing, you remove the positive and the negative, so it just turns into numbers. So now the 2 goes with aluminium, so it's Al2, and the 3 goes with the oxygen, O3. You get that? I mean, it's kind of simple. The entire idea is, when atom not satisfied with electron arrangement, it gives an electron to another atom that wants the electron to get a satisfactory electron arrangement, if you get what I'm saying. I'll do a re-recording. If this one sucks, I'll watch this later. But that's basically all of ionic bonds, all of Form 4, Chapter 5.1. So, yeah.